right, lesson 2.8, part B, continuing with inverse functions. And so we talk about some function notation. Example 5 here says let C of M be the cost in dollars of M ounces of mangoes. What do the following statements tell you? Be sure to use units. All right, so I'm going to kind of write this out. So C of M, M is the ounces of mangoes. So I'm going to put ounces of mangoes. That's equal to the cost. Okay, so when I look at that and I see C of 12 equals 0.75, I know that the 12 is the ounces of mangoes. So 12 ounces of mangoes cost, and the cost is in dollars, so it's 75 cents. B says C of 8 is equal to 0.5, so again, that's 8 ounces of mangoes. Cost 50 cents. But look at C. C is in inverse notation, so that's like C of y is equal to x instead of C of x equals y. So I'm just going to switch it back. I'm going to do the inverse of the inverse, which means this is C of 48 will equal 3. Remember, x and y switch, input and output switch when you do the inverse. All right, so then we know that 48 ounces of mangoes cost $3. I'm going to do the same thing here. So this means C of 12 is equal to 0.75, which is the exact same thing we had right up there in A. Okay, so you can rewrite it if you want to. I'm just going to put same as A. All right, example 6. Suppose W is equal to P of X is the average daily quantity of water in gallons required by a palm tree of height X feet. So P of X, and the X is the height, equals average daily quantity of water. All right, so this is equal to the water, which makes sense why it's W equals. So what does the expression P of 25 represent? Well, it's going to be the water needed, or the water required by a palm tree that's 25 feet. So amount of water required by a 25-foot palm tree. What does the expression inverse P of 25 represent? Well, remember that means P of... All right, so this just means that P of the water will equal, P of X is equal to 25. So this is the height of a palm tree that requires 25 gallons of water. All right, C says what is the equation P of V equals 50? Tell you about V. Rewrite this equation in terms of the inverse of P. All right, so first P of V equals 50. That means that the height is V and it requires 50 gallons of water. So V is the height of a palm tree. That requires 50 gallons of water. And then I want you to write the inverse of P. So the inverse of P equals, remember, just switch your input and your output. So, sorry, not equals. Well, there we go. So switch your input and your output. So it's going to be the inverse P of 50 will equal V. All right. D says palm trees are on their average Z feet high, and a tree of average height requires K gallons of water. Represent this fact in terms of P and the inverse of P. So P of the height, it says, is Z, equals the amount of water, which is K. And so if we're going to do the inverse, remember, just switch your X and Y, switch your input and your output. In this case, switch your K and your Z for the inverse. All right, so building on that one, says using the definition of Z and K, from part D, what do the following expressions represent? So P of 2Z, so this would be equal to K, so it's the amount of water required. For a palm tree that is, and then remember Z is the average height, so this is 2 times the average height. So double the average height. You could put twice the average height, anything like that. All right, 2 says 2P of Z. So that 2 is on the outside, so that's going to affect the amount of the water, okay? So, because remember, P of Z is equal to K, so this is like saying 2 times K. So this is twice the amount of water. Required for an average height palm tree. All right, 3, P of Z plus 10. That plus 10 is inside with Z, so it's affecting that height. So it's 10 more than the average height. So this is a palm tree that's 10 foot taller than the average. So let's see. We could put it's going to be the water required. For a palm tree that is 10 foot taller, 10 feet taller than the average. All right, 4, notice now that plus 10 is on the outside, so that's the amount of water. So that's going to be 10 gallons more water. Required for an average height palm tree. All right, 5. The inverse P of 2K, so that would equal Z. And so what we have here then, remember, is this means that P of Z equals 2K. And so this is just double the amount of water required for an average height palm tree. Six says the inverse P of K plus 10. Okay, so that's equal to Z, which means then P of Z will equal the K plus 10. So that's just the water plus 10 more. That's the exact same thing as 4. And actually 5 was the same exact thing as 2. Just another way to write it. All right, 7 says the inverse P of K plus 10. Now remember your inverse P of K, so that plus 10 has to do with the Z then, because this is equal to Z, so it has to do with the Z. So this is the same as saying P of Z plus 10 would equal K. And that's the same as 3. And then 8 says the inverse P of K minus 2. So this means P of Z minus 2 will equal K. And so that 2 is the height being subtracted, so it's shorter. So this is the water required. For a palm tree. That is 2 feet shorter than the average. All right, so tables and inverses. So F and G are defined by the given tables. Use the tables to evaluate the following. So the inverse of F of -4, remember then this is our output, so we're looking for the input. So this means F of X equals -4. So what is our X value? So go to your F table, find where your output is -4, and you can see your input is 5. So X is 5. All right, the inverse G of 6, it's inverse, it's going to equal to the X, which means G of X will equal 6. So we're going to go to our G table, look where our output is 6, our input is 8. So we know that X equals 8. Then we have the inverse of F of G of 1. So first let's go find G of 1. So go to your G table, and that's not an inverse, so that means G of X, so that's when X is 1. And we can see that's -3. So we're looking for the inverse of F of -3, which means F of some number equals -3. So go to your F table. We'll find where your output is -3. And we can see our input is +3. So X equals 3. And then D is the same idea. We have the inverse G of F of 0. So let's go find F of 0 first. So go to our F table. When X is 0, we can see that our Y value is -1. And so we're looking for the inverse G of -1, which means G of some number will equal -1. So go to your G table, find where your output is -1, and you can see that your input then is 4. So X equals 4. All right, to find the inverse of a rational function. So it's going to be the same steps that we did when we found a function in part A. So the first thing that we had to do was we needed to change f of x to y. So we know our equation is y equals 2x plus 3 over x plus 2. And then to actually find the inverse, this is where we switch the x and y. So every x becomes a y, every y becomes an x. And we're going to work to get y by itself. Now we have two different y's there, so the first thing we got to do is get rid of the fraction. So we're going to multiply both sides by the denominator. So we're going to multiply both sides by that y plus 2. So it gives me xy plus 2x on the left equals 2y plus 3. Then we go on to get our y's on the same side and our non-y's on the other side. So I'm going to move this 2y over. Doesn't matter which one we move. So our y's will be on the same side. And then I need to move this 2x over because it doesn't have a y. And so my non-y's will be on the other. So we have xy minus 2y equals 3 minus 2x. I'm just going to rewrite that real quick here. So xy minus 2y equals 3 minus 2x. And then both of these have a y in common, so we're going to common factor it out. And then just divide by what's in the parentheses so we can get y by itself. And so we get y is equal to 3 minus 2x over x minus 2. Now that will work. You could have also said it was negative 2x plus 3 over negative 2 plus x, okay? You could also change all of the signs. So we could say this is 2x minus 3 over 2 minus x. Either way, they're equivalent, okay? And the same thing with the other one, the original, we could change all of its signs. So it's negative 3 plus 2x over negative x minus 2. Any of these 4 ways are correct, okay? So if you go and look at my answer key and I have this one written down, check. Can I change all of the signs and get the same answer? Can my 3 become negative? My negative 2 is positive, my x is negative, and my 2 is positive. If that's what yours is, then you're still good, okay? So any of those will work. And then because it is a fraction, we need to talk about the restriction. So remember that your denominator cannot equal 0. So it doesn't matter which of these you choose. When you set your x minus 2 not equal to 0, you'll get x cannot equal 2. All right, so then you would put comma, I'm out of room up there, x cannot equal 2 as part of your answer. So like if I pick this first one, I know we're not supposed to box, but if I pick the first one, then I would write it like that, okay? So I'd probably put the x not equal to 2 up there next to it. Then B wants us to find the domain and the range of f of x. So the domain of the original function, we're looking at the original function. We know that x plus 2 cannot equal 0, which means x cannot equal negative 2. So our domain is going to be from negative infinity to negative 2 and negative 2 to infinity. Now the range, we haven't talked about how to look at an equation actually and pull its range, but remember the range of the function is the domain of its inverse. We just said the domain, oops, I know what I didn't do, of the inverse of f of x, which is what I need to do, is go back and write it in function notation, is the same as the range of the inverse. We already said that it was x cannot equal 2. So therefore, we know then this means it's y cannot equal 2 for the range. And so we know it's negative infinity to positive 2, and then 2 to positive infinity. And so what I really need to do right there is I did need to change it back to function notation, okay? So the inverse of f of x equals the 3 minus 2x over x minus 2, comma, x cannot equal 2. And so that would be how I would write that. Sorry about that. All right, then if a function is not one-to-one, then its inverse is not going to be a function. However, if an appropriate restriction on the domain is made, then we can find an inverse that is also a function. So when we end up with that quadratic one we had earlier, and we said it didn't pass the horizontal line test, we saw that it was not one-to-one, the inverse was not a function. We could have restricted the domain to make it be a function. All right, so look at example 9. It says find the inverse of y equals 2 minus x squared if x is greater than or equal to 0. Graph f and its inverse All right. So I'm going to graph y equals 2 minus x squared, which is the same thing as saying negative x squared plus 2. So I'm just going to use what we've learned in the past about the parent functions and stuff. So I know my parent function is x squared. It has that as a table. And so for this one, we can see that we're going to take our y's times negative 1, and then we're going to add 2. So my x's are going to stay the same. And my y's will multiply by negative 1 and add 2. Now, but it does tell me here we're only going to look where x is greater than or equal to 0. So I didn't really need those two. And that's the piece that we're going to cut off, okay? We like to cut off the negative numbers, the left side of our graph. This is going to force it to be a one-to-one function. Whoops. Okay, now just think about it. If I drew in the other side, we know it would look something like that. It would not pass that horizontal line test, okay? So that's why we have to restrict it, and it told us to restrict it up there in the problem. Now, it wants us to find the inverse of that. So our equation is y equals 2 minus x squared. And so remember, switch your x and y. And then we're just going to solve for x. So we're going to subtract the 2. Divide everything by negative 1. And then take the square root. Now, when you take a square root, you should get plus or minus, don't forget. But we only use up here the positive x's, so we're only going to use the positive side of this one as well. Okay? So, my inverse, well, I'll call it f of x. So the inverse of f then is going to equal the square root of 2 minus x. And so when I go to draw it, because I know it's an inverse, I'm just going to switch my x and y's. And it didn't tell us to, I don't believe, but if I drew in that line y equals x, I can see that they are reflections across each other. And now because this is a square root, we can also see that our x's that we're using are x's that are less than or equal to positive 2. And we could have also just done our domain. Remember, your domain of a square root is when you set the square root greater than or equal to 0, and you would have gotten x is less than or equal to 2 as well. Let's see, did it ask me for the domain? It did not, but I can look at the original one and see its range. So if I look at the original one here, we already know its domain was 0 to infinity because it told me so, and its range, so looking at it when I graphed it, was from negative infinity to 2. And so that is where this came from. Okay, it didn't specifically ask for the domain and the range of the problem, but a lot of times they'll write that restriction there on it, and they write it in inequality form instead of the interval notation. So only specifically when I ask for domain and range, we use the interval notation. All right, example 10. So suppose f of x and g of x are one-to-one functions. If f of 3 equals 5 and g of f equals -2, can you determine whether f and g are inverses of each other? Explain why or why not. All right, so what does f of 3 equals 5 mean? All right, well, f of 3 equals 5 means that the point (3, 5) is on f of x. So the point 3, 5, so the inverse would be 5, 3. So the point 5, 3 would need to be on g of x for them to be inverses. All right, so g of 5 equals -2 means that 5, -2 is on g of x. You can't have 5, -2 and 5, 3 and it be a function, okay? And we know that g of x is going to be a function. So therefore, we know that these two cannot be inverses of each other. So since g of x cannot have both points, all right, because if g of x had both of these points, it wouldn't be a function to begin with because the x would be repeated. All right, and that is the end of our lesson.